Hi everyone, we're going to find the critical numbers for our trig function here and find the open interval where f is increasing or decreasing, and also apply the first derivative test to identify all relative extremum. So the first thing I'm going to do, just recall that this is really sine of x squared. So I'll take the derivative of my function and I'm going to get use the chain rule. I'm going to pull that, so that's going to be 2 sine of x times the derivative of my inner function, which is cosine of x. And then we have plus our derivative of sine is cosine. Now we have to find the critical number, so I'm going to factor out a cosine, and that's going to give you cosine of x times 2 sine of x plus 1 equals 0. So cosine of x is 0 at pi over 2 and 3 pi over 2. And this one is sine of x equals negative 1/2. And that occurs at 7 pi over 6 and 11 pi over 6. And I'm going to go ahead and write these increasing, some smallest to biggest, so I can do my intervals. Okay, so I'm going to write these as my intervals, and again I'm going starting at 0, because you recall our restricted domain is from 0 to 2 pi. And I'm going to write it small here because I don't have room, so I'm going to write it like that. And then my next number was 7 pi over 6, so we're going to go from pi over 2 to 7 pi over 6. Alright, I gotta get smaller here. We get 7 pi over 6 to 3 pi over 2, and then we're going to get 3 pi over 2 to 11 pi over 6, and finally we go to pi over 2, so 11 pi over 6 to 2 pi, which is 12 pi over 6. And my derivative was 2 sine cosine plus cosine of x. And what I did is I just did midpoints, and I'm plugging in midpoints into, I should put an x here. I'm plugging midpoints, so midpoint between those two is pi over 4. So when I plug that in, my equation here, my sine is going to be positive number. When I plug in the midpoint between these two, I'm going to get a negative number. Midpoint of those two, or you can just do another, it's just somewhere in between these two values, you're going to get increasing. The same thing here, you're going to get decreasing, and the last one's going to be increasing. So basically we have increasing, or this is positive, negative, positive, negative, positive. So we have positive, negative, positive, negative, positive. Increasing, decreasing, and so forth. Increase, decrease, increase. So if you look at this, this is what's happening. You're increasing, then you're decreasing, increase, then decrease, and then you're going back. Let's see, I'm getting it right. Decrease. I should have did this a little bit over a little bit. Alright, so then we go decrease, we're increasing, then we're decreasing, then we're increasing. And so basically what we do is we have a maximum at pi over 2. We have a minimum at 7 pi over 6, these two. We have a maximum, again, at 3 pi over 2. And then we have a minimum at 11 pi over 6. And what I do is I'm going to plug it back into my original equation. My original equation was f of x equals sine squared, sine x squared plus sine x. And so for my increasing, we're increasing, I'm going to write my maximums were pi over 2 and 3 pi over 2. But I have to plug these values in to my original equation. And when you plug in, say, for example, f of pi over 2, you get sine of pi over 2 squared, which is just 1, plus sine of pi over 2. So that's going to be 1 plus 1. So that equals 2. And similarly, when you plug in, when I plug in 3 pi over 2, you're going to get sine of 3 pi over 2 squared plus sine of 3 pi over 2. Well, this is negative 1 squared plus 1, and that's going to give you 0. All right, and then we're going to do the same thing. So these are your relative maximum. And now we're going to do our minimum. And our minimum was 7 pi over 6 and 11 pi over 6. Again, you're just plugging it into your original equation. Which gives you a sine of 7 pi over 6. Well, this should be squared. Okay, plus sine of pi over 6. And that gives you negative 1/4. And also do it for 11 pi over 6. And you plug that in. That also gives you negative 1/4. So this is your relative minimum. Relative minimum. Okay, that's all. Thank you. Have a nice day. Bye-bye.